Okay, so in this video we're going to look at some of our properties of logarithms. Okay, so there are three primary properties that we will take a look at. The first, and these go either direction, is that if I have some log base b of m times n, that can be broken up into log base b of m plus log base b of n. And this is assuming that m and n are positive numbers and b is a positive number that is not 1. Now if I have log base b of m over n, that can be rewritten as log base b of m minus log base b of n. And last but not least, if I have log base b of m to the n power, that can be rewritten with the exponent as a coefficient of the log. So m times log base b of m. And these can go either direction. So that now, if I were to have log base 2 of, say, 8 times log base 2 of 2, that would equal log base 2 of 16. And by the way, we know that log base 2 of 16 would just be 4. Okay? Well, you probably that should be log base 2 of 8 plus log base 2 of 2 at the beginning. If you look at the original problem, that is a 3 and that is a 1, so that 4 holds true. If I try log base 4 of 128 minus log base 4 of 2, that would give me log base 4 of 128 divided by 2, which is log base 4 of 64, which we can evaluate because 4 to the third power is 64. I could even take an expression, so log base 4 of 2 of x plus log base 2 of y minus 3 log base 2 of z, and I could take that expression and make it written as a single log. So I could write it as log base 2 of x times y over z cubed. And the reason that I can get that is because the addition between the logs is the same thing as multiplication within the log, and the 3 coefficient is really an exponent on the z, and subtraction means that I'm dividing within. I could also move back the other direction, so I could take something that looks a little complicated, log base 2 of x cubed over y to the 4th, and I could write that as 2 separate logs. So that would be log base 2 of x cubed minus log base 2 of y to the 4th power, which can be written as 3 log base 2 of x minus 4 log base 2 of y. Or we even did some examples in class where I had the square root of 4x y to the 3rd all underneath a log. So that is all actually the same thing as 4 to the 1/2 power, x to the 1/2 power, y to the 3/2 power. Because having a square root is the same thing as raising something to the 1/2 power. So I could write that as log base 4 of 2, because 4 to the 1/2 power is 2, plus 1/2 log base 4 of x plus 3/2 log base 4 of y. So I just need to remember that these properties are only true if all of the values inside are positive, and the bases must be the same. So when I'm going the other direction, when I'm going this way, I can only add them or subtract them if the bases are identical to each other. If they ever are not identical to each other, then I cannot combine them.